Hey, IB Pre-Cal. In this video lesson, we're going to be reviewing how to evaluate trig functions of acute angles. So maybe you remember doing this all the way back in, geometry. That's actually where you started this, right? So it's like we learned right triangle trig. That's what we're reviewing in this lesson, right? Triangle trig. We also did this last spring, right? So we reviewed this as well last spring before we built on it with our trig unit at the end of last school year in marking period 4. So hopefully a lot of this stuff are things that you remember. We're going to obviously be building on this a lot and going farther with applications and stuff with this. So you want to have this good foundation. So after you watch this video lesson, I encourage you to maybe do this like right away. So this is the textbook work that goes with this video lesson. So I don't know why it likes to jump to a different page every time. All right, so trig functions. So we had these 6 trig functions that hopefully you remember, right? We had sine, cosine, and tangent, which were abbreviated as such. And they had these ratios, and they were ratios of sides of a right triangle. So sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse. Tangent is opposite over adjacent. Right? So these were the 3 trig functions that we started with. These over here are the reciprocal functions. Right? So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal function of tangent, right? So that means that the ratio is the reciprocal, right? So opposite over hypotenuse, well, it's hypotenuse over opposite, right? So this is the same thing as saying 1 over sine of theta of the angle. This is like saying 1 over cosine. This is like saying 1 over cotangent, right? That's really what's happening here. So we had this nice mnemonic device to remember these. Do you remember what it was? Oh, SOHCAHTOA, right? And that helped us to remember sine, cosine, and tangent. And you could write it at the top of your paper. SOHCAHTOA. Awesome. Okay, let's do an example. Find the values of all 6 trig functions of beta in terms of x. Oh, sorry. I got too overexcited. So let's see. Let's start with sine, cosine, tangent. Sine of beta, cosine of beta, tangent of beta. Sine is opposite over hypotenuse, so 3 over x. Cosine is adjacent over hypotenuse. Oh no, let's come back to that for a moment. Tangent is opposite over adjacent, so 3 over something. Oh no. Oh my gosh. Is it going to do it again? Why does it do that? So we need to figure out what this side is. It says in terms of x. So this is a right triangle. So hopefully you remember you can use our favorite formula, the Pythagorean theorem. It's used for like everything. Most important thing. A and B are the legs of a right triangle. C is the hypotenuse. So I could say 3 squared plus b squared equals to x squared. So b squared is going to be x squared minus 9. So b is going to be the square root of x squared minus 9. Be careful. This is what b is. Like this side length is b is the square root of x squared minus 9. I can't actually take the square root of that, right? If you factor x squared minus 9, you get x plus 3 times x minus 3. It's not a perfect square. So the cosine is the square root of x squared minus 9 over x. The tangent of beta is 3 over the square root of x squared minus 9. I could rationalize that if I wanted, but I don't know. Yeah, it's fine. If you want to say 3 times the square root of x squared minus 9 over x squared minus 9, go for it. So for the reciprocal functions, well, the reciprocal of sine is cosecant. So cosecant of beta is going to be x over 3. The reciprocal of cosine is secant. So secant of beta is going to be x, sorry, that's an interesting looking x, over the square root of x squared minus 9, which maybe you want to write it as x times the square root of x squared minus 9 over x squared minus 9 if you would like. And then the reciprocal of tangent is cotangent of beta, which I'm going to do the reciprocal, is the square root of x squared minus 9 over 3. Awesome. So, for example 2, if the cosecant of alpha is 7/4, find the values of the other trig functions, assuming alpha is at an acute angle. Right, so we're dealing with a right triangle. So think about, well, if this is the cosecant, what is the sine of alpha? 4/7, right? This is the opposite. This is the hypotenuse. I can solve for the third side, right? I can solve for the adjacent side. I can do that with the Pythagorean theorem. 4 squared plus b squared, or the adjacent squared, equals to 7 squared. B squared is 49 minus 16, which is what? 49, 39, 33. So b is the square root of 33, right? So this is the adjacent. Therefore, I'm able to say, well, I've got cosecant, I got sine, right? I can go ahead and say, well, the cosine of alpha is going to be adjacent over hypotenuse, the square root of 33 over 7. The tangent of alpha is going to be opposite over adjacent, so 4 over the square root of 33, or if you would like to rationalize, 4 root 33 over 33. Right? I've got the cosecant. I could then say the secant of alpha is going to be 7 over root 33, or if I would like to rationalize, that's 7 root 33 over 33. And then the cotangent of alpha is the reciprocal of this, so root 33 over 4. If you would like to draw yourself a picture, that's probably how you did it way back in geometry. You can, right? So if this is alpha, it doesn't matter which one of the acute angles I'm calling alpha, but it's telling me it's an acute angle. It's not the right angle. Then I would have to say, well, if this is cosecant, this is going to be the hypotenuse. This is going to be the opposite, which I already said. So it would be, this would be 4 and this would be 7. And I could solve for this side that way. And then if maybe I'm a little bit more visual, that works as well. So similar idea here with example 3. If the secant of y equals x, find the values of the other trig functions, assuming y is an acute angle. Sorry, I had a moment there. This is gamma, isn't it? I think so. All the Greek letters. Okay, so that means, so if the secant is x, so the secant, I don't like how I wrote that. Oh my gosh. Can I write that any better? Nope. That was worse. I'll just write y. If the secant is x, so like x over 1, the cosine would be the reciprocal, right? Which would mean that it's 1 over x. So cosine is adjacent over hypotenuse. So then I can solve for the opposite, right? So I've got 1 squared plus something squared equals to x squared. Let's solve this. Something squared equals x squared minus 1 and the square root of that. And again, like that's what the third side is. Like now this is what my opposite side is. So I've got secant, I've got cosine. So the sine is going to be opposite the square root of x squared minus 1 over hypotenuse, which is what? X? Yeah. I did cosine. Tangent is going to be opposite over adjacent. So I know the opposite is the square root of x squared minus 1, and the adjacent is 1. So I don't even need to write that, right? I could just say the square root of x squared minus 1, ideally. And then the inverse, or I'm sorry, the reciprocal functions. Wow, don't make that mistake. That's the wrong word. The reciprocal of sine is cosecant. So the cosecant is x over the square root of x squared minus 1. Or x times the square root of x minus 1 over x squared minus 1, if you would really like. And then the cotangent is the reciprocal of tangent. That's going to be 1 over the square root of x squared minus 1. Or, wow, I'm running out of room here. The square root of x squared minus 1 over x squared minus 1. I really squeezed that in. Right, so these are very similar. And again, like if you would like to draw yourself a picture, fine. Doesn't matter which one's gamma. I can't even write it. It's an acute angle, so we know that if the cosine was 1 over x, it's going to be 1 over x. And then when you solve for this, you're going to get the square root of x squared minus 1. And then you're able to figure out these other trig ratios, functions, because of that. Find the value of the other trig functions. I'm missing one. Okay, right triangle trig. So, oh no, I didn't want to close it. There we go, it's okay. Evaluate these trig functions. So this is 45 degrees. Oh, wouldn't this have to be 45 degrees? Right? This is an isosceles triangle. These two sides are going to be the same. This is going to be the hypotenuse. Maybe you remember some special right triangles. We even did these when we were dealing with the, what's it called? The unit circle. Maybe that rings a bell. So the cosine of 45 degrees, sine of 45, tangent, secant, cosecant, cotangent. I could be doing it of either one, right? So if this is x, and then if you're solving for this side, what are you going to get? X root 2, right? I mean, even if you wanted to solve that, x squared plus x squared equals the hypotenuse squared. 2x squared equals the hypotenuse squared. Square root both sides. You're going to get root 2 is going to stay. The x is going to come out. So x root 2 is the hypotenuse. So if we're going to do the cosine, let's write it. So good too. The cosine's adjacent over hypotenuse, so it's going to be x over x root 2. So you get 1 over root 2. Or you could say root 2 over 2. Maybe this rings a bell. What about the sine of 45? X over x root 2. You get 1 over root 2 again. Root 2 over 2 if you want. Oh, these should sound kind of familiar. The tangent is opposite over adjacent, x over x, which is 1. So the tangent of 45 degrees is just 1. And then the secant is the reciprocal functions, right? So the reciprocal of cosine, so I'm just going to get root 2, right? I did the reciprocal back here before I rationalized. The cosecant is just going to be root 2, right? I'm really doing hypotenuse over opposite and hypotenuse over adjacent. So x root 2 over x, I'm just going to get root 2. And the cotangent, the reciprocal of 1, is just 1. right? This is a special angle, right? This was one of our unit circle values that we learned about last year with 45 degrees. Remember, we did things with 30 degrees, 60 degrees, 45 degrees, 90 degrees. Right? Maybe some of that stuff rings a bell, or hopefully it does. So speaking of, what if we're doing 60 degrees, right? So there's a relationship here. This is my shortest side. I'm going to call it x. This side, the hypotenuse, is 2 times x, and this is x root 3. These are special angles, right? The sine of 60 degrees is opposite over hypotenuse, so you get x root 3. And ideally, you won't have to do this each time. I'm just showing it for right now. Root 3 over 2. The cosine of 60 degrees is x over 2x, which is 1/2. The tangent is opposite over adjacent, so that's going to be x root 3 over x, which is just root 3. Or if you hopefully remember, tangent is sine over cosine. So if I did root 3 over 2 over 1/2, remember we did the speed trig last year? We get to do that again. Extra c. The cosecant, that's the reciprocal of sine. So, right, 2 over root 3. Or maybe you're going to be writing 2 root 3 over 3 if you'd like to rationalize. Right? It's good to know that they're equivalent. The secant is going to be 2. It's the reciprocal of cosine. Cotangent, the reciprocal, is going to be 1 over root 3. Or if you'd like to rationalize, root 3 over 3. What do we think's coming next? My goodness, 30 degrees. I shouldn't have cleared that, sorry. So this angle up here is 30 degrees, right? So I still have the same thing. X root 3, 2x. So the sine of 30, isn't that going to be the same thing as the cosine of 60? Right? The sine of 30, opposite over hypotenuse, x over 2x, which is 1/2, is going to be the same thing as the sine of its complement. Complement those two angles that add to 90 degrees. So this right here is going to be the equivalent of this one over here. The cosine of 30 is going to be x root 3 over 2x, which is root 3 over 2. Well, that's the same thing as the sine of 60. The tangent of 30 is going to be the same thing as the cotangent of 60. Right? So that's going to be x over x root 3, which is just 1 over root 3, or if you'd really like to write root 3 over 3. 1 over root 3, which is root 3 over 3. The cosecant is doing the reciprocal of sine, which is 2. That's going to be the same thing as the secant, right? Make these connections. The secant of 30 is going to be the same thing that was the cosecant of 60, which is the reciprocal of the cosine of 30. So that's going to be 2 over root 3, or 2 root 3 over 3. And finally, the cotangent is the reciprocal of the tangent. So it's just going to be root 3, which is the same thing as the tangent of 60. Right? So those special angles, 30, 60, and 45. We probably want to know the 90s also, right? Those boundary angles. So let's do a little bit more. Let's talk a little bit more about what to do without a calculator. So these are now in radians, right? Which you got a review of at the beginning of that video lesson from last time, right? So the tangent of pi over 6, that's 1/6 of a semicircle. That's the same thing as 30 degrees, right? But I think it's nice, like if you're thinking about the parts of a circle. So the tangent of pi over 6 is going to be, well, you can think about the sine and the cosine if you would like. right? Root 3 over 2 over 1/2, which is just root 3. The cosine of pi over 3, so 1/3 of a semicircle, 1/3 of half of a circle. So that's the same thing as a 60-degree angle, right? 1/3 of that. So think about where that falls on the circle. Right here. What is the cosine of that? 1/2. Remember, cosine is x and sine is y. The cosecant of pi over 4, so that's like right here, 1/4 of a semicircle. Think about it in terms of sine is going to be 1 over root 2. So the reciprocal is just going to be root 2. Right? The sine of pi over 4 is going to be 1 over root 2. Or root 2 over 2. So what about these? So in example 8, it's the same thing. Like we're using these special angles or these unit circle values. Use the given information to find theta. Theta is going to be between 0 and pi over 2. So that's in quadrant 1. Right? We're talking about acute angles. It's got to be. Then translate your answer from radians to degrees. So where is, right? So now we're talking about inverse. When we're solving for an angle, we're going to be using inverse. So I'm saying sine inverse of root 2 over 2. Remember that this is the same thing as saying arc sine of root 2 over 2. Right? So sometimes this can get confusing because we're not saying this isn't the reciprocal. This is the inverse. That's the notation for it. So the inverse of where is sine root 2 over 2? Well, at pi over 4. That is the same thing as 45 degrees. Notice I'm not using a calculator at this point. Right? What is the cotangent inverse of root 3? So where is cotangent the square root of 3? Right? I mean, you can think about this and say, well, this is really saying where's the tangent 1 over root 3? Right, if you want to think about it that way. So in order to get to that point, I'm going to have sine over cosine. So my sine value would have to be what? 1/2. Where's sine 1/2, which would be where's cosine root 3 over 2. That's what's going to end up with this. So like break it apart if you need to picture it for now. So that is going to happen right here at pi over 6. So theta is going to be pi over 6, which is the same thing as 30 degrees. Right? So remembering these values and pulling them off, right? So like we spent a unit doing this. Now you're getting some quick review. So now with a calculator. So I'm going to pull up my calculator. There it is. Second mode. So evaluate with a calculator. Remember what mode you should be in, depending on what we're doing. I have pi over 5, pi over 7, pi over 8. So I should check, and remember the calculator defaults to radian mode. So right now I'm in radians. Good. Quit, go back to my home screen. These are not special angles, so we need a calculator for now to evaluate them, right? So I would go into my calculator and say tangent of pi over 5. So what is that? 0.727. Let's see, the cosine of pi over 7. 0.901. The cosecant of pi over 8. How do I put that in my calculator? Oh, well, shouldn't I just say 1 over the sine of pi over 8? I'll just do that. 1 over the sine of pi over 8. So 613. Maybe you remember things like sine and cosine are going to be between, like your outcome is going to be between -1 and 1. I guess I should have done this. Right? And same thing with cosine. It can equal to it, sorry. That's a good thing to remember. So using the given information, find theta, and theta is between 0 and 90. So what mode do I now need to be in? Degrees, right? So I've got to change it to degrees. Here, I'm trying to find theta. I need to use the inverse of sine, right? Which is the same thing as saying arc sine of 0.7. So be careful with that, right? So let's see. In my calculator, I'll go ahead and clear this. I'm going to change my mode to degrees. And I'm going to do second sine of 0.7, which gives me 44.4 degrees, or 43 degrees, 44.4 degrees. Right, between 0 and 90, so acute angles. The cotangent of theta is 10. So I want the cotangent inverse of 10. Well, that's an interesting one to put into my calculator, right? Maybe I want to do 1 over the tangent inverse of 10. Right? So, or I want to do the tangent inverse of 10 and then do oh no, I don't. Sorry, my friend. What do I want to do? I don't want to do 1 over that because it's not the reciprocal of that. It's the reciprocal of the ratio. I'm very sorry. So I would want to say this is the same thing as the tangent inverse of 1 over 10. I do the reciprocal of the outcome. Sorry. It's not the reciprocal of the angle. So I could say tangent inverse of 1 over 10. And that would give me 5.71 degrees. Right? So let's see. Let me double check that. So then if I did the tangent of 5.71, it's going to be approximate. And then I did 1 over that, I get about 10, which is what the cotangent is. 1 over the tangent of something. Very small angle. Right, so just pay attention to the mode and what you're using here. Remember that your calculator defaults to radians. A few more. So solve for x. I'm going to try to figure out, this is the hypotenuse, right? Here's the acute angle that I have. Here's the adjacent. So I need to know that I'm using cosine of 39 degrees equals to 23 over x. So when we solve this, we're going to get x equals to 23 over the cosine of 39 degrees. 39 is not a special angle, so I would need to go into my calculator. Oh, it's there, isn't it? I need to be in what mode? Degrees. So 23 divided by the cosine of 39. So I get 29.6. Given alpha is 41 degrees, given C is 10, solve the right triangle below for all its unknown parts. So let's see. I should know beta right away because I can do 90 minus 41. Right? 90 minus 41 gives me 39. So this is 39 degrees. Right? I can solve for, I don't know, I'll solve for A. And I'll use sine. Sine of 41 degrees equals to A over 10. So A is going to be 10 sine of 41. I'll go into my calculator momentarily. And then if I want to get B, I don't know that I want to use a rounded value. I think I'll probably just say the cosine of 41 equals to B over 10 so that I get an exact. Or I'm not rounding on top of rounding. Right? So B is going to be 10 times the cosine of 41. I can go into my calculator and I get 10 times the sine of 41 and 10 times the cosine of 41. So 6.56 and 7.55. Right, so working with right triangles here. So our last question, given beta is 59 degrees and A is 5, Alex started to solve the right triangle below for all of its unknown parts and realized something was wrong. What was it? So let's see. The cosine of 59 is 5 over C. So C is 5 over the cosine of 59 degrees and got 9. Let's see, is that right? 5 over the cosine of 59. That's pretty rounded, right? I probably would have rounded that to 10, but that's okay. So he referred to this as 9. We'll say, I don't know. And then the sine of alpha would then be 5 over 9. So then you can use the inverse of sine to solve for alpha. When you go ahead and do that, sine inverse of 5 over 9, you get about 34 degrees. How's that? This is 34. What's wrong there? What should these two angles, alpha plus beta, should be 90 degrees. They should be complementary. Right? But when you do 59 plus 34, what do you get? 59 and 34. You get 90 what? 93? You get over the amount. Remember how you can store things in calculators? I could say 5 over the cosine of 59. I'm going to be using it again. I'm going to go ahead and store it, right? So maybe I'm going to store it as alpha A. Maybe I want to store it as C. Alpha C. Right? So then when I'm going to do this over here, I can do the sine inverse of 5 over alpha C. And I get 31 degrees, which how much more sense does that make? Right? So using that. So that's interesting, right? So like that rounding did that to him. Okay, so that's where I'm going to finish up with this. And so hopefully most of this was review. We really didn't have anything new in this. It's just almost what we learned for several lessons in AAF in the spring into one. So you guys have that textbook work that we encourage you to do maybe now or let this sink in for a little bit and then go back and do it. And we will see you next time. Actually, can you guys hear that train? Bye, everyone.